I think she can do.
Okay.
Okay, perfect. Good morning, everybody. Good afternoon. So, I am Rachele, and today we will have this conversation about my research topics, and I'll try to introduce you to my studies and to my last work result. So let's start. Here we have a brief agenda of the presentation, and first of all, I'm going to introduce myself. So I'm a PhD student at University of Catania in the program in Complex System for Physical, Social, Economic, and Life Science. It's an industrial PhD realized in partnership with the Neodata Group, and we just signed a supervision agreement with the University of Seville in the PhD program of Industrial Organization Engineering. My PhD started on October 2024, and before this, I've worked as a process engineer at the ST Microelectronics. And my academic backgrounds are a bachelor degree in industrial engineering, a first-level master in smart manufacturing, production engineering, and predictive maintenance, and a master degree in management engineering at the University of Catania. My PhD project was named the Circular Industry Analysis and Operation of Sustainable Business Models, aims to develop new best practice, guidelines, and operational policies to guarantee the efficiency of these new circular business models in the current industrial sector. By doing that, it aims to provide incentives with companies to facilitate their transition towards circular economy. As a PhD student, I'm a member of a different project, and in this case, I'm realizing my first secondment here in Pontevedra, Vigo, within the work package 3 of the Explicit project. So let's move on to the context and the objectives of my last works.
Può farlo in questo computer?
Ok, okay. Okay.
No, arriva nell'aspa, è per chiudere quella da...
Ok, perfetto. So let's move on. As previously said, my research focused on circular economy and its application, because in the current industrial environment characterized by the lack of resource and raw materials and high competition, as well as a strong environmental awareness of the customers, there's a need to create a new sustainable system for both the production, distribution, and consumptions that use regenerative cycles where companies can reduce their waste generation and at the same time improve utilization and recovery of resources. Clearly, this transition from a linear economy to a circular economy brought to the born of new circular business model. This new circular business model, as a consequence, have a different supply chain structure. This new supply chain structure and configuration need to be studied and analyzed to understand its feasibility, the requirements, the role of stakeholders, as well as information and materials flow. In particular, today, I will talk to you about closed-loop supply chains and industrial symbiosis. Closed-loop supply chains are systems where product, materials, and components are reintegrated in the same supply chain. So after the end of life, products are reintroduced in at one point of the supply chain. Based on the point, the member of the supply chain where the return is reintroduced, we may have reuse, repair, remanufacturing, recycle, and so on. while industrial symbiosis is built upon resource exchange between different supply chains. So the waste or byproduct generated by a film process is used as an input for another film. So the exchange between two firms, two supply chain. Moving on, it's important to say that nowadays more and more disruptive events such as natural disaster, wars, as well as strikes and labors or disease are affecting the industrial environment and the market, and as a consequence, the supply chain's performance. So it's important that these new sustainable systems that we've mentioned before are resilient. But what we meant with resilience concept, the resilience of a supply chain, its ability to manage and to face a disruptive event. Specifically, we will talk about its ability to absorb disturbance, and we will talk about absorptive capacity, its ability to adapt for an unforeseen event and by undergoing some changes, its ability. So it's the adaptive capacity and the system ability to be repaired, its restorative capacity. So the aim of this work, this presentation, is to presentation of circular economy approach, such as the one mentioned before, closed loop supply chain and industrial symbiosis, serves to improve supply chain resilience in terms of its absorptive, adaptive, and restorative capacities. To address this research question, we developed a simulation model of a supply chain, and we evaluate its resilience under a disruptive event by using the resilience curve. So the model, as just said, combines a closed-loop supply chain, closed loop of return products, and symbiotics exchange. So in addition to the traditional linear flow of material and information, we will have reverse flow. There are return goods from final customer that are sent to the retailer of the same supply chain, and a symbiotic flow that is byproducts generated by a second supply chain manufacturer. They are treated and then sent as an input for the manufacturer of the first supply chain. Here's some assumption of the model. We start from a single product model with a normally independent identically distributed demand. We choose moving average as forecasting technique for demand for each echelon of the supply chain, and order up to as replenishment rule. We assume that a portion alpha of end-of-life products that we would call return rate represents the portion of a product that at their end of life are sent back from the customer to the retailer. And then a portion omega of byproduct rates that we will call byproduct rates that represent a portion of waste or byproduct that is generated by the second supply chain and sent to the manufacturer on the first supply chain. We consider reverse flow as symbiotic for us prioritized over raw materials, virgin raw materials, and the products and the content realized by reverse and symbiotic flow are considered good as new. Starting from this, we select simulation as a methodological approach and define a different set of scenarios based on different values of the return rate and the byproduct rate. Then, as disruptive event, a sudden demand spike is selected, moving from a mean of 100 for 500, such the one that happened for laptops during the COVID period. Basically, we compare each circular supply chain scenarios with the forward supply chain scenario. The forward supply chain is the one with only the traditional linear flow. So no return flow and no symbiotic flow. And then, as I just said, different circular supply chain were generated by changing the values of return rate and byproduct rate. And then we compare the two scenarios. So to assess and evaluate the resilience of a system, usually it's the resilience curve is used, which tracks changes over time in a performance measure for a specific scenario. In my study, the performance measure selected is the fill rate, which represents the percentage of customer orders that are successfully fulfilled. And then we constructed the resilience curve using the fill rate. Then, following the framework, there's something. No, I don't know what's going on. I'll go anyway.
Stop sharing and try again if you want.
Okay.
Yesterday it worked.
How to stop the sharing. Okay, perfect. All right. I'll try again. Momento. Try. It's certainly not make my PC. So wait for a second. So then I think I can change this slide.
I can too.
Okay,
Yeah.
so from here, that's no problem. So as just said, we used the resilience curve to assess the resilience of the system, and in particular, following the framework established in literature, we defined a set of metrics, the resilience metrics, that are divided into two microgroups: time-based metrics that are absolute duration, end duration, and recovery duration, which quantifies the time between two milestones. Milestones define the transition between phases. We will have when the disruption occurs and the system starts to then the system degradation starts, we will start the absorptive phase will start. Then when the system degradation ends and it starts its end duration, while the performance is stabilized at its minimum level. And then when with the end of the end duration, we'll have the start of the recovery phase. So when the performance starts to again to increase till its end, and it's defined as the recovery phase. While performance-based metrics are failure ratio and recovery ratio, represent respectively the lost and regained performance compared to the performance before the disruption occurrence. So what we have done basically is build resilience curve of manufacturer and retailer in the first supply chain, and then compare this resilience curve with the forward supply chains one. We generated two scenarios for both retailers and manufacturer and compared with the forward supply chain scenario. So here's some results starting from the scenario where we are considering 0.4 as return rate and 0.4 as byproduct rate. Here there's the retailer resilience curve for the fill rate, of course, and the results shows that in the comparison between the forward supply chains, there's not absorptive capacity improvement. In fact, as we can see in the left side of the figure, we have the same resilience curve, the resilience curve, and we have no absorptive duration or performance lost. The performance lost is the same. While looking at the left side of the figure, we can see that there's an improvement in the end duration of the circular supply chain scenarios, which means that it persists at its minimum level for a shorter period of time. And then he starts to recover quicker respect to the forward supply chain, which means that the the cumulative recovery performance of the circular supply chain scenario is higher than the one of the forward supply chain. That also can be quantified with the recovery ratio. Moving to another scenario where we have improved the return rate from 0.4 to 0.7. The results show that there is also an improvement in the absorptive capacity of the resilience system, retailer system. In fact, we can see that here we have absorptive phase, which is characterized by an absorptive duration. That means that the system performance do not immediately drop to zero as done for the forward supply chain, but we have still residual performance when the disruption occurs. That's led to a shorter end duration to its delayed start. So the end duration start on different times for the circular supply chain, and also by the earlier start of the recovery duration, which means that the system starts to recover before than the forward supply chains, and so the total the cumulative recovery performance, which is represented by the area below the curve during the recovery phase, is higher than for the forward supply chain ones. And here we also have shorter recovery duration, which means that the phase of recovery is shorter, and so that the system reached again his highest level of performance before than the forward supply chain. And we have done the same analysis also from a manufacturer point of view. So we built the manufacturer resilience curve for both supply chain, circular supply chain scenarios and for the forward supply chain scenarios. Here's some results. We find out that for moderate values of byproduct rate, here we are just focused on byproduct rate because we analyzed from the analysis conducted by manufacturer's perspective. So just the symbiotic flow is interested. In this case, for a moderate value of byproduct rate, such as 0.4, there's an enhancement in the resilience capacity, particularly as shown for moderate value of return rate and byproduct rate for the Rachele resilience curve. There's firstly just an enhancement in the restorative capacity. Specifically, we'll have a shorter under duration for the circular supply chain, and a shorter restorative duration, resistive duration for the circular supply chain. And as a consequence, it reaches its highest level before the forward supply chain. And the cumulative recovery performance confirmed that there's an improvement in the restorative capacity of the circular supply chain. While by increasing the values of return rate from 0.7 to 0.4, further enhancement is observed. In addition to the restorative capacity improvement, we also have an improvement in the absorptive capacity that are introduced in a higher absorb duration, a non-zero absorb duration, such as the one for the forward supply chain. In fact, as we can see, there's the system performance degradation start at a different time for the circular supply chain one, which means that the cumulative absorptive performance during the absorptive phase is higher for the circular supply chains, which means that the performance absorbed is higher. As a consequence, we have a shorter under duration due to its delayed start, and due to its to the system recovery phase that starts before for the circular supply chain and reach its highest level before. So we can say that for moderate value of circular rate, so byproduct rate and return rate, the restorative capacity are always enhanced by the circular supply chain application. And so return flow and byproduct flow may strengthen the resilience and the response to a disruptive event. By increasing the circularity rates, it's shown that also the absorptive capacity is enhanced. So there's the possibility to enhance absorptive, restorative, and adaptive capacity by by adding, including circular economic practices within the supply chain. In particular, as I just said, we considered byproducts, return byproducts, and return flow. So a closed loop supply chain and industrial symbiosis to increase system supply chain system resilience. So as a next step, we want to study different disruptive event scenarios for the circular supply chain, regular or unforeseen. For the regular ones, we want to introduce AI as a predictive model for the disruptive event. And then a series of case studies will be conducted and will be included in the deliverable 3.2 for within the explicit project context. And the result presented will be also presented at the MIM 2025 conference, which is a conference on manufacturing modeling, management, and control that will be held in Norway at the start of this July. So here we are. Thank you. I want to say a special thanks to you for letting me give me the opportunity to this seminar. So thank you.
I have many questions.
Many.
What is simulation environment?
Simulation environment, we used Python, primarily Python. Yes.
Okay, so my first question is about, so you are using a model with one products.
It's a single product for the moment.
And do you think that it's possible to make the model more complex? I think at least more than one products, but not in the sense of different products, completely unrelated products, but products that means that's used to in the production and manufacturing of the single product that they're using for the simulation. For example, components is this car, no? Because it's very abstract now. And understanding the first level of simulation, I think it's already like great that you have done incredible work because you just started now, basically, a few months ago, the PhD. So how do you think it is possible to make a more complex model which you analyze a variety of different components for the single product that this company or this production factory, whatever it is producing? Because this is super important, because when you use like this is a very abstract level. A single product can be anything, but if you are talking about cars or you're talking about PlayStation, that this was under the COVID was like we had like bottleneck. People like were demanding PlayStation, and there was like shortage of microchips, for example. Mm-hmm. So it's not just one product. It's about, in order to produce this product X, you need hundreds of different products, and then the resilience of the supply chain becomes extremely complex to measure. Right?
Yes.
How do you see? Because the kind of finding is not surprising in the sense, and it is okay at this level of PhD. Just starting. So it's not surprising because, of course, if you're you're using things, you realize less on external provision of products. So it is not so surprising, the results that you have. But if you add complexity of multiple components to produce PlayStation, and then you can also create the tools for, providing some ideas or alternatives to the company to be more resilient. I don't know if I was clear.
It was clear. Yeah, I think that it can be applied for components. So for products that need more components to be constructed. So I think it's possible, but in this way, the complexity of the supply chain and the network is higher. So we have to consider that this factor. So it surely becomes more difficult to analyze the resilience.
Yeah, no, I mean, for example, you can make a simulation which you are producing one component or one product using 4 components. These 4 components are coming from different places, right? And you can start like, oh, just 2. You can start with just 2, 1 product and 2 components. I think this is super interesting how. So you can add level of complexity of the number of components to produce single units. No? And then a second question was like, do you think that you can add also the geographical location of the components of the resources that this unit of production is using in manufacturing? Because I think this is important. Imagine that you have you can model this and you can say, okay, now this this disruption is forcing us to look at local resources. I don't know, in agricultural sector is quite common, or replace minerals with other things that can be provided locally. So you don't have to go to China, for example. I think this is, I don't know if you thought about it, but I think this can be super interesting.
No, yes, for sure. This could be super interesting studying the disrupting events such as wars, for example. That some channels or distribution channels can be disrupted and others not. So it could be interesting.
And how can you model it? You have an idea of this?
For the moment, no, but I think that's interesting.
Okay. And fine. We have a lot of questions. I really like simulation stuff. I think it can be super interesting to add like a political aspect in this and see like political implication. I know that now it's maybe it's too early for your PhD, but maybe having a models like we have done in Just to See, for example, the project Just to See. I don't know if you are familiar with that model of supply chain explorer. Yeah. I can give you the link. So we have this map in which you have the different countries, and we have input-output models with a number of sectors, a number of raw materials, and basically you can see, imagine aluminium, for example, use and production in Spain, for example. You have a map, and you say, okay, 80% of aluminum is coming from China, whatever. And then associated with this, you also have social variables, for example, labor legislation in China, or women employment levels, or injustice, for example, conflicts, and so on. I think can be useful in the final model for your PhD to add some political aspects that can lead to political implication, in the sense, policy implication. For example, we prove that under certain condition, increasing circularity in value chain in this specific sector will increase the resilience after some disruption. And acting on this level with a specific policy can help companies or cooperatives or whatever to increase this resilience. I don't know if I was clear.
No, it was clear. It's really interesting. It could be an idea.
Okay. Because otherwise, it remains very abstract.
Yes.
Which is fine, but now what we can do with this simulation, no? I'm talking Arabic or ancient Greek, or is it?
No, it's good.
Huh?
Yeah, thank you for the presentation. I like it a lot. Wanted to ask you what is the objective of your thesis, because I guess this is like a sort of paper, no?
Yes.
So it is an objective for you, like to have to like deliver a model at the end of the thesis, or just to generate knowledge about resilience in circular supply chains?
The objective is more to develop a model that is flexible and can be used for various sectors. So the aim would be a model, a simulation model for the safer supply chain.
Okay, because I mean the work you presented today is very good in terms of you have a hypothesis that you are going to deep now on it, no, and I guess that you will need like real case studies, no, to
Yes.
because I was wondering how you did the simulation because you told us some things, but I guess that you hide a lot of things.
We have talked for hours if I put everything. So yes, the mainly data are taken from literature data. So in this particular data are not from a case study, but we want to move towards this analysis. So.
And what about the sort of supply chain? Because in the explicit, for instance, I don't know exactly what you are doing actually in Civil, no? But I think that they are trying to model supply chain beyond the typical way of creating supply chains, like I guess post-growth scenarios. And they are trying to understand how supply chains look in post-growth scenarios to model them. I don't know if you have engaged with this or you are planning to engage with this. And actually, I mean, we don't know what are post-growth supply chains, so we have prof.
Nobody knows.
But I don't know if you are working with it in explicit or if you are going to engage with it in the future.
I think we are going to engage it in the future. That's why, as you know, I've just started, so we're just trying to.
Okay.
Yeah, sorry, fascinating. Now it seems obvious, no, that of course there are these metrics to use to be analytical about resilience and supply chain and stuff. But half an hour before, I didn't even think about it. And I saw the results. The results look great, and then I thought like, damn it, I missed some parts of what you were saying because I was stimulated, and I was thinking like, okay, but probably there are some assumptions, and there are some, and I think I got some of them, but I missed some. So my first question is about performance. What is the meaning of performance? It's only about production. Probably you said it.
As a performance measure, we use the field rate. Field rate, so the percentage of orders that are successful orders from the supply chain member, each supply chain member.
Just like demand.
It's
Yes,
the possibility to fill the order.
With the inventory. No,
Yeah, both to order.
Yes,
So it's
yes.
like production.
yes, it's
Oh,
a
okay, it's
from
like
production point of view. We
Okay.
can use
It's
different
just
measures.
it's or
Yes,
percentage.
percentage in this case, it's
So,
percentage.
particular
Yes.
product, yeah. Yeah. So
The other performance indicator can be used.
okay, makes sense. Yeah, that was my intuition. That was, and is there any assumption about the differential of costs of bringing it from raw material or get it circularly? So it's like equal cost.
Yes, we
Ah,
didn't,
okay.
in this case, we didn't concentrate on costs, but it could be an interesting point of view
Yeah, that was my main concern.
Okay.
Here.
about costs.
Yeah, because I mean it's
We-
different.
Yes, we
Yeah.
just consider as prioritize the reverse and the reverse and ventral flow, but we didn't analyze.
Yeah, of course, we have to start with something and it looks great. Also, equal quality.
No, we
raw
consider
material
equal
and-
quality,
okay.
good as
Like it's equal, like we just want some things. Okay. But like,
It's-
looks like you have a fair diagram. Experiment and stuff. Yeah. Great. Awesome.
Can I ask something else? What is resilience? I mean, you use the field rate and you have this rates that I don't remember the names, the one that decrease and the one that decrease. But when do you say that something is resilient? It's like there is a limit, over it is resilient. And
not really. We just concentrate. With the resilience is the ability that a system has to face a disruption mainly. So we consider more resilient or less resilient compared to the forward supply chain. So we use the forward supply chains as benchmark to say there's not a level.
So it's the capacity to restore production. When
no, I mean, the concept, I understand it. I didn't know if there is a number, over it, you consider it to be resilient, and if not.
Sounds like it is a suite of metrics. Is that when you approach, you try to analyze inequality? I mean, it means many things, and you need like a battery of different indicators to like absorption. You have like many things. I don't know if eventually you have like a output one number or something. You try to aggregate like to a synthetic indicator, or you display the different ratios like adaptation and so you display many of indicators.
Yes, I displayed many indicators. I think that they can be presumed in just one, but we just focused on single indicators, a single metrics comparison.
Like a topography or something.
But that's the x-axis was the time, no?
Yes,
Okay.
time and performance.
Okay.
So the
So
time-
it's really like about the time that people that's
If you
okay,
give
very
criteria
simplified,
to solve
is the
something-
time of it that takes a company to restore production after disruption. And that's all.
Yeah.
No?
Well, but there are other things there,
Yeah,
like
there's
how
other-
deep it is, because that's also cost.
Yeah.
Slopes, but
And how do you want to use the case studies? I think it can be very powerful in the sense that you have like a real case study in which you have single company facing disruption, assuming that you have access to the data and people will give you the data and see if your model is like really pretty one. And then, you should be have comparable kind of cases, right? A case in which that is totally linear, and a case that is, experimenting with some sort of circular. I don't know. I think it's quite complicated, no? How are you going to use the case study in your case? Like to test your models or?
mainly to test the model. I think that in some cases we just propose some circular practice. So I don't know how, but I think it's impossible, almost impossible to compare, to have the same scenario, circular and linear. So just with the experimental data, trying to.
So I think eventually probably you will do it, but putting like currency there, I mean like money, because in the end of the day, I mean you are more interested. I mean the companies are more interested in profits than in if I can respond or not. So
Always it.
because of the two styles of supply chains.
The social science wing of the group is completely silent, overwhelmed. Yeah, we can engage with the Hegelian epistemology if you like. Challenge the Hegelian epistemology if you like. No? Okay. So, no other comments? How long you will?
It's the end of February.
Okay. We still have a couple of weeks. So we can do the just to see. You're not familiar with just to see.
No.
I mean, okay. I think there is a lot of things that you can use in just to see. Especially also the social part of supply chain. We also have models, macroeconomic models that you can have a look at it. For example, there are stock flow consistent models. I don't know how you can engage with them or use it, but there is a lot of interesting things, especially because we try to model what's happening at the political level when a country is going circular, and when two countries together that are connected in terms of supply chains, for example, are going circular. And there are a number of trade-offs that can be explored. So it's super interesting. So maybe you can, get inspired by that kind of. We produce more than 100 papers on. And there is the tool as well. Okay. Thank you.